In the previous video about chapter 5, we talked about the concept of having agile infrastructures. What's that mean? Well, it means that they are accessible, available, maintainable, etc., uh, and how we can keep them very much available to us even in times of disaster. In this part of the discussion on infrastructures, we're going to talk about sustainability and some other issues that are very important, especially in the 21st century, in the last 2 decades, in terms of information systems infrastructures. The first is this concept of sustainability. Now, sustainability simply it's an interesting approach to how we can keep information systems operable inside the organization while still being efficacious to the business. And this is very important. And the sustainability concept, it's easy for you to say, the sustainability concept is the fact that because of Moore's law and some other factors, we have this massive turnover of electronic equipment. And it's pretty amazing how fast things are outdated. For instance, consider your cell phone right now, or I don't know why we call it a phone. It's basically a computer with a radio attached to it. But consider it. How many of you, this is a question I like to ask in the class, and obviously I won't get an answer here, but how many of you are still using the very same cell phone that you very first had? Probably not too many of you. One or two, maybe. Most of you are on the second or third, maybe even the fourth generation cell phone you have, and the new i12 or whatever it is, the iPhone came out, and we all got to jump in to make sure that we're able to use this wonderful new mobility that we have available. I'm not a big fan necessarily of the fifth generation of cell phones, mainly because in order to get that kind of power, you have to shorten the bandwidth, speeds it up considerably, and these 5G phones are producing an awful lot of radiation. I'm concerned about that, but that's a different issue. But I might as well express myself anyway. I would do the same thing if I were seeing you in person. So anyway, but the concept of sustainability boils down to the fact that we go through information systems, software and hardware rapidly. And in order to maintain, to keep things operating, a lot of people think that we have to, while we can maintain this system, we have to stay on the leading edge. Sometimes I refer to that as the bleeding edge. So, in order to do this, it takes some quite a bit of effort. So, what drives sustainability? Well, first of all, we have to make sure that we have and understand perfectly well that a sustainable system is one that's going to optimize costs while we are in the process of maintaining an agile system. And we don't want, at least we shouldn't want, it to have a negative environmental impact. Now, we got a big problem here because in order to be sustainable, we have to continually update. And as we continually update, what we're doing basically is causing more and more computer waste, which is a major problem. So we have to somehow come up with a way in which we can have usable systems and yet have sustainable products. And this is a balance, and it's a balance that we oftentimes have some issue reaching. Okay. So we need to be able to make sure that while we want to keep our systems up to date, and we'll talk a lot about how we can do that, it is a major problem to make sure that we're not wasting a lot of money, and in the process, we're not wasting a lot of resources. So this is what the drivers of the sustainable system are all about. And here we are. We have all of this electronic gizmos. And I'm sure a lot of you have 2 or 3 cell phones laying around in your house that probably you don't use. I imagine if I were out checking in some of our old storage areas, I could probably find 2 or 3 cell phones that haven't been used for several years. They're just laying around. Well, this kind of issue creates a problem. What do we do when we are finished with the old equipment? And remember, Moore's Law says about every 18 months, and Moore's Law is getting a little long in the tooth. It says about every 18 months or so, we get double the processing power. And well, some people have predicted we're going to plateau because we're in silicon. The issue is we're looking at other ways of computing. One of the things that if we'd have had more time and if I'd have not gotten sick and a few other things, we'd have looked at some of the future developments of information systems, because it's very important that you understand that. And, one of the big issues that's coming along is moving away from silicone chips to other types of processes. For instance, one of the big deals, I guess would be the easiest way to put it, today is called quantum computing. And quantum computing will make the computers we have today look like horses and buggies as compared to an all-wheel drive super fast Tesla. It's going to be amazing. And so what we know is going to happen, we're going to continue to advance, and as we advance, we're going to have to try to sustain our systems. And yet, as we do this, we're creating an awful lot of computer waste. So the next slide talks about environmental pressures on having a good sustainable system. And it says IT produces toxic waste. And that's basically it. Amazing. And you can look at these. This slide talks about heavy metals, arsenic, cadmium, mercury, etc. Some of the issues that are in the production of electronic things like PCBs and in your plastics and PVCs. There's all kinds of issues that we have that create this awful waste, and we're filling we're filling land areas. Having trouble thinking tonight. We're filling all these land refuge places with this amazingly toxic garbage. And there's a good reason that we should be concerned. In the next slide I present here in terms of sustainability talks about some of the issues that can cause some of the elements that are in computers can cause really major problems in terms of the human body. And you can go through this list, but the problem is that these things are toxic. They can get into the water supply. They can make the land unusable. And so what you end up with is a mess. And I've given you an URL that I'd like for you to watch about what on earth we're doing. But then the next slide just talks about some of the pressures of the sustainability of information systems and information technology mainly. And that is the fact that we're producing so much garbage, so much e-waste, as it's called, that it is a major problem. Now, I'm old enough that it's not going to impact me that much. But you and your children, because you're young enough to be my grandkids, and your children, when you have them, could be my great grandkids, you're going to be faced with a problem because we get all of this, as this slide on environmental pressures talks about. You can see that we're producing a massive amount of waste right now, and it's going to continue to get bigger and bigger and bigger, because what we're doing is the faster we produce new businesses, electronic devices, the faster people want them, and the faster we turn them over. And this is a problem. So, something needs to be done. What needs to be done? Well, we need to make people environmentally aware that this is a problem, and we need to come up with solutions somehow. And I don't have the solution. I can't tell you what the answer is. This is a problem for you guys to start thinking about and working on. What are we going to do about the e-waste? It's a big problem. Okay. The next topic I want to talk about is the idea of grid computing. Now, grid computing is an interesting concept, and it's one that, if we could take it to its extreme, would be one that would be pretty amazing. I want you to consider, okay, right now at Ball State University in the College of Business, in the good old Miller College, we have 3 computer labs that have 48 stations each. That's about 150 computers there. Plus we have a couple other smaller labs that have about another, if you add them all together, about another 50 computers. So we got almost 200 computers sitting on the 2nd floor in the Miller College of Business. What's going on with them right now? Think about it. What use are those computers right now? Nothing. They're just sitting there, idle computers. Nobody's doing anything with them. Well, we talked about having an agile, flexible system. That's one of the things we want. It's one that we can grow and or shrink as computing needs arise. And this is part of sustainability. Is how on earth can we keep a system, usable system, agile system, that one will fit our needs as we have needs? Well, think about, we got these 200 computers sitting idle, doing nothing. And if you consider how many computer labs there are on campus, which I have no idea, but there are a bunch of them. When you stop and think about this, how many of those labs are being used right now? And the answer is nobody, none of them, because we sent all you guys home. Not only are you sitting at home, you're going to be sitting at home for the next 2 months, basically, because when school starts, I've been told we're going to be online for the first however long, and I guess I've been told my class is going to be one of these online guys again, and I'm real thrilled about that, but can't do anything about it. So one of the solutions is this concept of grid computing. And what is grid computing? Well, grid computing is very simple. We have all of these computers sitting there doing nothing, and they're networked. They're all networked. I don't think there's a computer lab. Well, there isn't a computer lab on campus that isn't networked, which means that all these computers are linked together. You understand networking by now, so they're all linked together. Well, the concept of grid computing is simple. If you have all of these computers available, and if you took a huge, massive job, just a biggest computing job you can think of, and chop it up in little bits, that each little bit could be processed by a processor, we could distribute all of those little pieces of the job out to each of these individual computers that are sitting there, and each of these computers could work on the task together. And basically, after they come up with a solution, send their part of the solution back to a big server someplace. Essentially, what you have is what would be considered a supercomputer. Because all a supercomputer is a computer that has massive processors inside it. Well, if you have a large network all over the place with lots of computing power attached to it, you basically have the very next thing. So the next slide that I have here is just a picture of how a grid computer works. You have this controlling server, control node is or node. I'm sorry, it's what it's basically referred to. That node, the control node, breaks the job up into lots of little pieces, distributes it to each of these computers. Each of the computers does their own thing, and sends the results back. The advantage here is you get amazing computing power by doing that. Plus, you're using unused computer power, which is critical. Because think about all of the computing power that's sitting idle right now at Ball State. It's pretty amazing. Okay. So if we did this, we could harness using grid computing a lot of massive computing jobs. Remember, we talked about big data a little bit. At least I had you do an assignment on big data. And we could do all of these various kinds of things. And I've given you a list of some of the areas where grid computing could be used. Ideally, if we had, and there's some issues involved here, but if we had the ability to link all the unused computers together, just think of the amount of computing power would be available to us. Now, there are issues like security issues and networking issues and some other things that would have to be resolved, but potentially it would be an amazing way of getting much more sustainable systems. The next topic I want to talk about is virtualization. Now, virtualization, what the term virtual simply means, it appears to be, but it isn't. If that makes any sense. We use the term virtual reality. Now, what's virtual reality? Well, virtual reality is where you can put on a headset. You've seen this advertised on TV lately. You put on a headset, you give yourself some controllers, and you can go into what appears to be a virtual world. And with gamers, they love this stuff because you can go in and you make yourself part of the game, seems like. Okay, so basically what virtualization is anything it seems like it is, but it isn't. Now, what's that have to do with the concept of having a sustainable system or a system that is very robust, agile? Well, what virtualization, I should say, refers to is a way of taking a server and using unused server space, which is pretty common, so that instead of running just one job on a server, we can run multiple jobs on a server. Okay? So it looks like virtually we have several computers when in essence we only have the one computer. Okay? So server virtualization is where we have a single large server. Now, servers, again, remember, a server is a big, powerful computer that has lots of storage and computing power. Okay. So, what we can do with virtualization is by using software, we can make it appear that this computer is two or more different computers. That sounds kind of odd, but basically the way it works is pretty simple. We have this software that is going to set on the computer that's going to make it look like we have lots and lots and lots of computers or servers. The next slide I talk about here is why do this? Well, servers are expensive. You can pick up a desktop or a laptop, $1,000, $1,200 or under. Not much, not much. Servers, on the other hand, are $8,000, $10,000, $15,000 each. They're powerful and they've got a lot of storage, and therefore they're pretty expensive. So we have servers, and oftentimes in a business you'll get a server for email, you'll get a server for one department, a server for another department, etc. Very costly to do that. Not only that, servers take a lot of power. They run a lot more because they're more powerful with more storage. It takes more power to drive them. When they crash, we got problems. And it's a very high cost. So the concept of virtualization, if we can do it, makes a lot of sense. So we have what is called this hypervisor. Now, excuse me while I put on my glasses here because it's small print. Okay, hypervisor is simply a piece of software. That's all it is. Okay. I have a picture of a typical server and a virtualized server. The only difference between those is that the virtualized server has this hypervisor. What the hypervisor is a program that interacts with operating systems. Now, remember, an operating system is what we have in a computer that allows the user to use the computer without too much effort. Okay. The hypervisor is a program that allows us to put multiple operating systems on a single machine. That's basically what it does. So when we virtualize a server, what we're doing is putting in this hypervisor. It in turn allows us to have these multiple operating systems setting on top of it. So the operating systems go through the hypervisor, which gives each of those operating systems a virtual picture of the kind of computer they need to have to operate. Think about it. It gives each of the operating systems a view of what they would think would be their computer. So you can have different kind of operating systems that interact with the hypervisor, because the hypervisor is a piece of software that basically is going to give us this interface between the operating system and the computer. It's another interface that allows us to have as many operating systems as the computer is capable of handling. So the beauty of this is that now we can have multiple operating systems on the same server running different jobs simultaneously, while the hypervisor keeps track of what all's going on, the applications within the hardware, within the actual server. Okay? So the advantage here is that instead of having 20 or 25 servers, we might be able to do the same work with 5 that are virtualized, which is great because oftentimes we have a lot of unused server space, especially if we're only running one application. So if we're running multiple applications on a single server, it can save us a lot of money. It can, in terms of not only equipment but also power, in terms of space. There's lots and lots of reasons to do this. Okay. Virtualization is an amazing technology that has really taken off, especially in the last decade or so. So I've given you a URL to explain it further, and I think he does a wonderful job actually of telling people exactly what virtualization is. Then we want to talk about the cloud. Okay, now, cloud computing. What is cloud computing? Well, the term's around everywhere you look. And what is it? Well, what is the cloud? The cloud is anything that is using a hosted service available in the internet. A hosted service. Now, what's that mean? Well, it means that we have these various businesses. Amazon's a big one, AWS, Amazon Web Service. Amazon's a huge one because what they do is they will allow people to use their equipment, software, through the network for a fee. Okay? So basically, what it is we have lots of businesses can't really afford massive computing power. So what they do is go to the cloud. And what's that mean? Well, you all go to the cloud anytime you're using applications that are cloud based. Do you store stuff out in the cloud? Pictures, for instance, or videos? Well, probably. So essentially, what you're doing is using other people's equipment to store your stuff. Google's a big cloud user provider. IBM is a big cloud provider. Dell is. There's just amazing number of people, or number of businesses, I should say, that allow for cloud computing. It's the term basically is you'll hear it all over, and the reason we call it the cloud is to try to draw a picture of the internet. You can't because it's constantly changing, so we just anything referring to the internet is drawn as a big cloud. So what kinds of things can we do with cloud computing? Well, what do you want to do? It's a better answer. What do you want to do? Well, you can do basically anything you want. You can run applications. You can use the cloud as a platform to do certain things, or you can create a complete IS infrastructure on the cloud if you want to. It depends on how busy you want. So we basically have three forms we talk about, and that's SaaS, PaaS, and IS. SaaS, PaaS, and IaaS. And it basically stands for software as a service, platform as a service, and infrastructure as a service. Now, almost all of us use SaaS because if you ever run a program that's cloud-based, you're using SaaS. A lot of the apps on your cell phone are cloud-based. The software is available in the cloud, and it's basically all this is the ability for us to, instead of having put software on our device, we can use software someplace else, which makes sense because it alleviates a lot of the storage. We don't have to maintain the software at all. We don't have to, the support's going to be there, but we have to do it under the auspices of the cloud provider. They're the people that control the software. We can use the cloud for a platform. What's that mean? Well, it means I can go to the cloud, and if I want to have some development stuff, if I'm going to build up some software, I can go out there and if I don't have the right equipment, I can go lease it, basically is what you do, or just rent it, I suppose would be a better way. where you use what you need, and the providers give you all the tools and everything you need to have a computing platform, which is kind of cool because you don't have to buy it. So if you want to use it for a while, great. Okay. Finally, we have this infrastructure, and the infrastructure is where you can rent a complete information system out on the internet. We just talked about virtualization. You can get your own virtual machine, you can have your own software, everything you need on, and this is one of the keys, on a on demand basis. In other words, and this is why it's so important in terms of sustainability and the ability to be very agile, is because you use it when you need it, and you pay for it as you use it. And that's one of the major advantages here. So end users can end up, you can do basically anything you want on demand at the time you want it. You can lease it, and they have ways of paying it. So it's a pay per use. You pay for what you use, and this is kind of the cool thing about it. Flexibility is incredible. We talked about scalability. Scalability, grow or shrink. No problem if you're using the cloud because you're not a person who's maintaining the hardware and the software. The vendor, the cloud vendor, is the person or the company that's providing the hardware and the software. You're just using it. One of the downsides, of course, and there are some downsides, is you don't have complete control over your own data. Now think about that. You don't have the complete control over your own data. And what is the second most valuable resource of any organization? Information. And where do we get it? From our data. So we could say data is that important. It's one of the most valuable resources we have. And when we go to the cloud, we have issues, potential issues, not necessarily, but security is not 100%. There's no guarantee. Downtime's not much of a problem. The reliability of the cloud servers are pretty good, but we're going out on the internet. And when you go on the internet, you open yourself up to an awful lot of issues. And I've listed a few of those issues with cloud computing here. One of the biggies is lack of standardization because each of the providers has slightly different ways of doing things. And so let's say I'm working on a Google project and I go, whoops, I don't see what I need here, but Amazon has it. Well, there could be a tremendous issue of porting our stuff from one system to another. And so you have to be careful when you go about using the cloud, okay? But there's no question about it. Cloud computing has become exceedingly important, and it's one of the biggest issues in terms of where we're headed in terms of information systems. I've given you a URL about cloud computing, and I would suggest to you, especially before you want to take the test, you may want to review these URLs because they're really very informative. I'll see you later.